vehicle that has a propulsion system, and it needs to move 6 feet up a ramp and down a ramp. And we need to make 3 main parts using either the laser printer or the 3D printer.
So our goal in this project was to build a vehicle that was able to move up and over the ramp, as well as carrying a tennis ball in it, which stays on the whole entire time, especially when it gets to the end, the tennis ball doesn't fall off.
We had 2 major constraints of this project, which was that the footprint of the vehicle had to be 6 by 12 inches, and the other constraint was that we had a budget of a garage sale value of $20. A motor to steer the wheels.
Our ideas were to have a balloon with an elastic system to help propel it over the hill. We also thought about doing just an elastic system, but we ended up going with a motor and gear.
Our first 3 ideas, we decided that we had one idea where we would use a motor to power gears that would just turn the axle, and then we were also thinking of actually putting a powered fan on our design and having that blow air into a sail that would be built onto the chassis. And then our last idea, we thought about just winding up rubber bands and attaching those to the axle, so that the rubber bands would spin the axle as they expanded.
And can we figure out the diameter?
So if we just did it by like 5 by 8.
We were given the task to create a seat for this tennis ball to sit in, and I designed this using the computer. And basically, so I measured the tennis ball, so I knew where to start. And then on the computer, I made sure that this hole was wide enough so the tennis ball can sit in and be secure.
Parts. We did 2 gears from the 3D printer, and we had this one attached to the axle because we're using a motor, so we had to make sure that it would spin correctly. And then this one we had to make sure that it was the right size so that it would fit on the motor. And then for our box, we used the 3D or the laser cutter, and to make sure that it would be the right dimensions to fit the tennis ball.
Fabricated part is this box right here. We're going to use to hold the tennis ball. Then we also fabricated the gears on our car. So we made sure they were just the right size. And then we fabricated the entire base of our car using the laser cutter. And we even cut out the hole using the laser cutter. And lastly, we made our bearings on the 3D printer.
Our car, and we realized that the 3 volts wasn't strong enough for our battery, so we're switching to a 9-volt battery.
Our problems are that the gears on our wheels when the wheels move from side to side, the gears aren't lined up anymore. And then, so we need to create a spacer that will allow us to keep the gears in line while the car moves. And then also we're having a connection problem. When we connect the wires to the battery, the connection is not strong enough to move the car uphill with the friction on the wheels.
We have a major issue because we hot glued the gear to the motor, but once we hot glued it, the motor was spinning but the gear wasn't, so that means the car's not going to move anymore. So we either need a smaller battery because this is too strong, or a smaller gear, we're not sure.
Aren't perfectly circular, which means that as the gears turn, sometimes they'll slip, like right. Okay, it's not doing it now. But sometimes they were slipping. So to make sure that that they were tighter, we just put a toothpick under the motor, and that should make it the connection a little tighter.
Let's do it, babe. We didn't put some trash on the wheels.
So we're going to change our wheel size because with this wheel, one full rotation only goes to about there, but with this, it does almost 3 times the distance. So we're going to change our wheel so we can go further with the same amount of energy.